Hello everyone, welcome to the past paper discussion. So we are in the 10th question of this particular series. So let's get started. It's a logarithm based question. Right, so let's get into this. It is gonna fetch 7 marks for us. Stars are classified by their brightness. The brightest stars in the sky have a magnitude of 1. The magnitude m of another star can be modeled as a function of its brightness b. And we can see a magnitude is mentioned as m over here, and brightness they have used b, and we have modeled the logarithmic function. Now there are some few sub questions, the easiest ever questions we have. The star called Acubens has a brightness of 0.0525. This is the brightness of Acubens. Find the magnitude of Acubens. Very simple, just a substitution. The modeled equation we have, magnitude I need, so m should be m only. That's what we are searching for. 1 minus 2.5 log 10 in place of brightness. Brightness of Acubens have to be feeded in. And that's it. Using a calculator, just we can solve this for. Right? And moving to the calculator page. Solving an equation for B. Take a calculator and go for menu, algebra, numerical solve. So my equation is m is equal to, and I have this 1 minus 2.5, then times logarithm function is there, log with base 10. Let's choose this. Log with base 10. And brightness of the Acubens is over here, 0.0525. And we are solving for, equation is done. We are solving for m. Or directly also you can solve. So we got 4.1996. Right, I'm switching to the solution page now. Okay, what I got for m? 4.1996. So approximately we can just say 4.2. This is magnitude of Acuben. Right? That's simple. Now next part. Magnitude of another star series is 7 and least brightest planet, star. Right? This is the least bright star visible without magnification. Find the brightness of the Ceres. So again, same thing. Here we are just finding the brightness, right? So m is equal to the same 1 minus 2.5 log with 10b. This is the model function. In this Ceres case, I have a magnitude. So 7 equal 1 minus 2.5 log 10b. You can directly go to the calculator and solve for it. Right? Switching to the calculator now. Okay, in this case, it's an end solve again. So algebra and end solve. I know m here, which is 7. So let's 7 is equal to 1 minus 2.5 times, and the same thing, log with base 10, but I don't know what is b. Brightness is unknown here. So that's it, comma. We are solving for b. And just click enter. We got the brightness. Right? And switching to, that's it. Very simple process. Just if you know the calculator stuff, you can solve it. Here we go. So what we got, b is equal to 0.00 3981. So 3 significant figures we can take. So this is the brightness of Ceres. Now moving to the next part. Okay, next The star Proxima Centauri has a greater magnitude than the planet Neptune. The difference in their magnitudes is 3.2. Find how many times brighter Neptune is compared to Proxima Centauri. So the given stuff, let's convert into math language. Proxima Centauri has a greater magnitude. So Proxima magnitude, let it be PM. Okay, just for a notion. And Neptune's magnitude is a comparison. Difference in their magnitude is given as 3.2. So what should I, like it is PM minus NM or NM. So this is the difference. And PM, Proxima Centauri has greater magnitude. So I should make PM minus NM equal 3.2. Okay, this is what we got from the description. Okay, so how to find the magnitude of Proxima Centauri and magnitude of this. Okay, if you got a confusion, you can just use in this way also, like magnitude of Proxima Centauri minus magnitude of Neptune equal 3.2. Any way you can take, and the second way, I think it will make better sense, right? Okay, magnitude, we know the model. So it is 1 minus 2.5 log 10. Brightness of whichever, like we are solving for Proxima Centauri. So brightness of the Proxima Centauri, right? Then minus 1 minus 2.5 log with base 10, brightness of the Neptune equal 3.2. So few more simplifications we need to do. Why? Because here we have two unknowns. I hope you can see that, right? So two unknowns, and we have to compare brightness of Neptune compared to how many times brighter the Neptune is comparing to Proxima Centauri. So we have to make a ratio of brightness of Proxima and Neptune. Okay, let's go. So let's simplify 1 minus 2.5 log 10 brightness of P. You take the minus inside, minus 1 plus 2.5 log 10 brightness of Newton equals 3.2. So here this plus 1 minus 1 will get cancelled. And I can take a 2.5 common out this. We can't cancel it. Brightness of Neptune and brightness of Proxima Centauri is different. So 2.5 you take it common. Log 10 brightness of Newton minus log 10 brightness of Proxima Centauri equal 3.2. And we want the ratio of Bn by Bp. Next, I will transpose this over the right side. Sorry. So I will get log 10 Bn minus log 10 Bp equal 3.2 by 2.5. Again, so I want the ratio, like how many times Neptune is brighter than. So B brightness of Newton, how many times then brightness of Proxima Centauri. This is our aim. Okay, so we should structure out in that way. Log m minus, so here we have a formula. Let me just give you, it is available in the formula booklet itself. The basic law of logarithm division part. And you know this too, but just for a reference. So this is available in formula booklet. If you are using this over here, you can condense this logarithm, log with base 10, Bn by Bp equal 3.2 by 2.5. I want this ratio, brightness of Newton by brightness of Proxima Centauri. If you transpose the log 10 to the other place, it will go 10 raised to the power, right? 2.5. That's it. And we have to switch to the calculator and solve. This is very simple. You convert into a normal number. So Bn by Bp equal, when you solve it using your calculator, you will get it around 19.0546. Okay, now brightness of Newton is equal, when you approximate it, 19.1 times brightness of Bp. We can express in this way. So How many times? Newton is, sorry, actually Neptune. So Neptune is 19.1 times brighter than Proxima Centauri. That's it. This completes the solution and very simple, easily we can score marks. So for the upcoming videos, so stay in touch and keep learning. Thank you so much for joining today.